Hi, I'm Toby K, and this is another tutorial on V4 Gamma. This one comes from a request from the element chat from Christoph, looking for a tutorial on how to create and manipulate classes, so create operations on classes, and also sort classes. We're going to look at an example today I call exploding barrels, meant to emulate exploding barrels from some video game. Imagine these red things are barrels we're looking at from the top, and if I click on one, they go bang like that. So each of the barrels manages its own little state. Have I exploded or not? A little bit of animation, and we'll get to sorting them later and a way to address them or change the way you address them through some sorting. The first thing we're going to do is create a definition of a class. So just type class there, and that's going to be barrel. It's a class, which means it's mutable. I've done this big tutorial before on mutability. I'll go into it a little bit here, but if you need more information on mutability, that tutorial is out there. These barrels are going to be rendered in Skier. So actually the first thing I'm going to do is add Skier to the project here. Right clicking there. Then I should be able to type renderer. Make a little Skier renderer already. Let's put that over there. Let it go. There you go. Portrait style today. So the first operation we're going to make on the barrel class is going to be to draw so that we can already see them straight away. So here I'm going to go into operations and create an operation called draw. And then what I like to do is create a frame around each operation as well. This is just visual, doesn't affect anything with how V4 actually interprets anything here, but I like it just to organize things. So what are we going to draw? We're going to draw a circle. That circle process draws one in Skier. And we're going to do an output. Now, that's turned white because it's actually assigned to the other operation, create. We want to click on the output pin, assign it to draw, and that will also assign everything connected to that output pin to draw. Okay, I'm back out here on the main page. I'm going to turn on, somewhere here's a little window that can show me key and mouse display. Where's that gone? Yeah, so I navigated back by pressing Alt left key. I do that a lot, but I think that's the same as this back button up here. And I saved, because you should always save. Okay, so now if I type barrel in the node browser, you'll see the two operations that we talked about, and I can put barrel.draw here on my main patch. Notice there's no barrel.create, but it's not null, it's given a default barrel, but it's recreating it every frame, and it draws a circle. There we are, one circle. Let's animate that circle. If we go into the draw operation on the barrel class, let's create a damper node. Now, if I connect this position to say we want to scale, I'm going to use a map and a map clamp node, which means it won't exceed the limits that we put on it. If we take the position of the damper and let's make an IO box so we can read the position of that damper and connect map clamp to circle should just have you have one value for radius. And then so this is something. You'll see this immediately took the color of the operation, but this one didn't because there's an IO box in the middle. Just something that happens. So I have to assign that by clicking on the link to draw. And then we get an error there. Let's deal with this error before we go any further. So what this error means in this case, when you've got a process inside a class and it's saying something like that, it generally means it hasn't been able to create itself properly. Damper is an animation node that keeps its own internal state. So it needs to be able to do that. And that's because the class was never created. It just used this uninitialized default. So what we need to do for the rest of our little prototyping here, we're going to create a pad called barrel. We'll use a different structure later, but this is just temporary. And we need to actually make sure barrel.create is run. We would need this anyway because if you're going to do animation, it would always be stuck on the first frame if it recreated itself every frame. Now that error's already gone, but I should press F9 and actually reset it so that definitely that barrel gets created and it's the one that's being drawn. Now damper is certainly not complaining, says it's updating there. Okay, let's continue with this animation. So let's say the circle, we're talking about its size here. So it's going to read the damper position, and between 0 and 0.8, the circle is going to go from a size 0.08 is circle min to a maximum 0.25, or it's actually radius max, radius min. And if I put for now put a 1 there. There we go, goes there. And it's going over a time of 1 second. And damper isn't a linear animation. It has a nice little bit of curve at the start and end. You might know it from v4 beta, always looks nice. Let's keep working on the animation here. We also want it to change color. So I'm going to use fill. Going to use fill to give the circle a color. There it is. Currently the color is still white. And then there's a nice, let me move this down. There's a function called smooth step that kind of works a bit like, not really map, but I forget what this was called in v4 beta. But anyway, basically I can put a scalar value in there between 0 and 1, which is what damper will be. And that's going to change between two colors. Put that there, and we'll make the first color red-ish. Oops. Yeah, maybe something like that. And let's have a look. Yeah, we have a red-ish barrel. Still don't like that red. What red did I use in the original example? I'm just going to copy paste it. There it is. There we go. And if I go to position 1, boom. Last part is we want, after it's exploded, we want it to fade out. To do that, let's do a set alpha RGBA. So that's going to set the alpha channel specifically of this color that goes in there. And we'll do another map clamp connected to the position of the damper. And this one, you might remember that one from 0 to 0.8. This one's going to go from 0.8 to 1, reading this value that always goes from 0 to 1. And it's going to fade the alpha from 1 to 0. Put that in there. We go to 1, bang. There we go. There's our little explosion. We can also run it in reverse. So actually we never want the explosion to run in reverse. What we want to do is, if the value is ever going back between 0 and 1, we have different times. So the way we achieve that, we need to actually make that an integer 32. That's a float, but the integer will implicitly convert to a float. And we're just using 0 and 1, so integer is actually fine to use the input value there. And when we make that high, it will have a damper time of 1, and when we make that low, it'll have a damper time of 0, meaning it should animate when we go up, and when we go down, it just snaps. Okay, so now we have an explosion animation. This operation is called draw, but really it's also running the animation logic, and we're going to separate those because of the way this little application is going to work. So actually, I'm going to say this stuff is animation. And you know, it's up to you how you divide it. You might say, oh, the color conversion is actually drawing or whatever. In Skia, we often use a cache region around drawing functions. This can save performance. It caches the layer at the bottom and only redraws it when inputs to the cache region change. In this particular application, drawing is so simple that it won't really make a difference, but I thought I'd show you as it's something we would typically put in a draw operation on a class like this. Notice also those links lose which operation they're on, so we have to reassign them. Not they're up here. And so to be clear, what happens is that everything's calculated up here, but what happens inside that cache region is not recalculated until those inputs on the border control points change. So now what I want to do is take this and make it a new operation. We're going to create the operation up here, and we're going to use an operation. We're actually just going to call it update because I want to show you. Update actually always takes this color dark gray like the process nodes normally take. And again, I'll draw this. More accurately, I could probably call it like update animation. But update is a shorthand you should use for something that you want to run every frame. And in this case, this damper animation node should generally run every frame for it to run the way we expect it to run. Now it's time to create some pads that will allow us to communicate between these operations. So if I create pad, and we're going to have a property here, this is radius. And we'll have another one here, pad color. It's already started putting these on the update operation. Once you have an update operation, I think it assumes nodes should be on that quite often. But these are still on draw, so we'll assign that to update. Whoop, what's that upset about? Okay, so when you see a bug like this where it still somehow seems something's on the wrong operation, you can just drag select everything and assign update. That should work. Also notice down here, these were assigned to update. You've always got to keep an eye on these colors. You assign that to draw. There we go. So colors are rather important when we're looking at operations. You may notice already here that some of the colors are different. That region has a blue color rather than the typical gray color. And this is actually a theme I made. If you go up here to themes, there's one here called high contrast. This theme was made in response to a request on the forums from Burke about how to make v4 better for users that may have some kind of color blindness, which is quite common. I just took some colors from the notes of somebody else who's more of an expert, and all the operation colors should hopefully be distinguished for people with various forms of color blindness. Totally optional to use it, of course, but if you'd like to, I drop the link below in the description. Okay, so let's make this update operation actually work. So the draw operation is called, but the update operation is not. Unsurprisingly, if we type barrel here, we can create the update operation. It doesn't like being out there by its own. And then it's already running. Now here's where mutability comes in. Mutability of this class means that it can mutate itself. It doesn't have to be saved back into a pad generally in order to update its values. It can directly update its own values, which means I don't have to create verticality with the operations. However, generally I will create verticality with the operations because I still want to guarantee an order of operations. Otherwise, the order of operations is not guaranteed and might change even between different times I load the application. Still, it's one of those rules that's made to be broken. Just going to Control L, neaten this up, neaten it all up, go on. One of those rules that's made to be broken because there are great times that mutability means you don't have to make things in a big vertical stack. And let's just test it. Put the 1 here, bang, great. Okay. So we've got a barrel, it explodes nicely. What we want to do is have multiple barrels. So let's change the structure out here to draw that. So I'm going to get rid of all of this. And we're going to create a new pad called all barrels. And that naming will be more important a bit later. And I'm already just going to manually type it, give it an annotation here, spread barrel. So it's going to be a spread of barrels. And we're going to create those barrels. And I'm going to start using processes to contain the things I do to the classes here. But this is mostly just for visual organization. I could have this just all on the application patch. And this is going to be called create barrels. Create barrels will go over there. Oops. Create barrels. And we're going to put another pad. In fact, it's a copy of the same pad. All barrels is going to be above and below this. You'll see why in a second. Create an input here that's going to be, again, barrels. In fact, let's call it all barrels. Also, and an output, all barrels. Love that. Oops, move that down there. Also give this the same type annotation, spread, barrel. Might not have to do that, but I like to do it if I know that's exactly what it's going to be. We're going to create an if block. And then I'll put a little bang on it now so we can trigger it. To create the positions that the barrels will be in, there's a very convenient node already, random spread 2D. To actually make them random, this needs a seed, and we're going to use another random node. This one's actually in advance these days. Random from 2. This actually is what simply gives us a random number. We'll go from 0 to, I don't know, 15,000. And plug that in there. Not particularly good randomness, but fine for this job. Fine for state work. Count 25 barrels, that'll be nice. Nice amount. And then we'll use a for each loop to say what happens 25 times. Put that to splicer, so that'll be 25 positions we get when this is triggered. And on those positions, we need a barrel create. Okay, so how does the position here get into the barrel? We need to actually set that up. So if I go into barrel, create another pad position, that should also go through a border control point on the cache. Not that it should update, I don't think. But all the same, if it did, we would want it to redraw. So that goes into there, and then I'm going to start using another little visual thing I like to do. All right, if I want to select everything and move it down, including the frames, you have to hold space as you do that. I'm going to create another frame up here that I like to call properties. And that's when I just put the pads, I'll put them all, radius, color, because you'll see me use these a bit more later, position. And position is something we want to be set at create, so it gets an input pin. If I hold control and left click and assign that to create, then if I go back out here, it should now appear as a pin on the create operation, and then the position can be there. If I connect output of barrel to the output of the for each, then to the if, then I'll be able to connect to the output. Do need an input to connect through. So only when this is banged should 25 things be created. This is still not connected out here, so nothing happened yet. So what happened to that mutability before? Why do we need to have a pad at the bottom? When you're creating a class, even though it's mutable, you still need to tell v4 where you want it saved, or else, yeah, it basically only exists for the moment that it's created, and yeah, it's never saved anywhere. So it still needs to be saved somewhere once in order for that location to be mutated next frame, basically. So now this should work. If I right click here, alt left, go back, then mouse over here, you see we've got 25 barrels. Great. So now we need to update and draw the barrels. For this, we can use a for each loop. We have a spread of barrels. We need to operate on every single one. They need to be barrel update as well as barrel draw. And we need to use a group spectral when we have a spread of layers in Skier to turn them into one layer that gets drawn. And there you can see we already have a bunch of barrels being drawn. Great. Let's neaten all this up. If I select it, press Control L. Yeah, like that. Move this down. Then let's start to do the fun bit. Create a process called mouse explode. For this, we're going to need to set up another layer input into the renderer because that's the way mouse works in Skier, that actually you use the kind of output system where you normally draw layers. That's also how it gets the right context to use the mouse. We need to use the right group here. Yeah, it's this one. So this will support a second layer that we'll need soon. So mouse explode is a process we'll create here. And in here, we're going to use mouse, which is the graphics Skier IO one. You notice this has an output context, which is a layer. I'm going to name it layer. And that layer needs to connect over here. And using this, if I get position in world and move this over the mouse, over the renderer, you'll see you get the mouse value there. Let's make this interact with some barrels. If I do an input, all barrels, and I'm also going to do an output, all barrels, because I want to maintain this verticality thing. These, though, are just going to connect straight like that. And I'll explain why in a minute. Again, I'm going to type this spread barrel. So here I can already insert this in the chain, all barrels, and also from the thing here, we want to do an if region. If is on left pressed, left mouse button. And let's do a tog edge so that turns that into a bang. If I press and hold it, it still only triggers once. Put a thing there, click. Yeah, that's doing the right thing. Goes on the if region, and then what happens when we left click is that we want to go for each through every barrel. So that comes from this spread, goes in here in the splicer. Then we want to check each barrel's position against the mouse position. So to do that, if I go barrel, I've got no operation yet that would give me that. So I'm just going to put draw there, even though that doesn't make sense yet. But just so I can go inside the barrel definition again. And here I'm going to get the position by creating an output pin. And when we create an output that's just for one operation, we normally just name it after the property. But if there's any ambiguity, you could name it get position. But I'm just going to name that position. Then here, if I cancel draw, I should be able to, put position in. So it's going to go through all those 25 barrels, going to get their position, and we're going to say, there's one other property we need actually to do this. We need radius. Radius, we don't create, by the way. Radius is set by the animation system. New operation. Yeah, we also want to get an output here, a getter that we'll just name radius. So we need the barrel's position and radius. And you may already guess what we're going to do. We're going to calculate the distance between the mouse and the barrel. And we're kind of brute forcing this. Like every time we click, we're going to do this for all 25 barrels. There's more optimized hit test methods like octrees and all sorts of things, but that's far too complicated for this particular problem. When the distance is less than the radius, hit tests are really easy with circles. When the distance is less than the radius, that should mean we're within. When that happens, we're gonna trigger the barrel to explode. To do that, we need to change this value from 0 to 1, and that also becomes a property that we're going to call explode state. It's an integer, and it should automatically become 1 when that's connected. Explode state, and then what we're going to do over here is actually nothing. I'm going to create another operation, and this one kind of, maybe I could have created over here in my little properties block, but I kind of do this sort of thing separately. This is going to be set explode, and in this, we're going to connect not an input, but an IO box to make the explode state 1. There you go, they all went because that's on update by default. We go assign that to new operation, set explode. Great. Then out here, we're going to create barrel, set explode. Operations like this that don't have output pins, if you press configure, you'll always be able to hit show apply, which is the equivalent of putting them in an if block. But don't connect it first because, well, actually all our barrels already exploded, but yeah, connect it second or it might apply because that apply pin is true by default. Okay, back out here, we need to create our barrels again, and actually this should have had a input pin to do this outside. Do create. Oops, don't like that though. Want those swapped. Just going to do it the quick dirty way and move that over there. Great. So do create, right click that. There we go, got our barrels back. And if I click on one, oh, I've screwed up. So you see I made it do the opposite of what I wanted to do here. I think I just need to swap these so that, yes, the distance between the position of the barrel and the mouse cursor is less than the radius of the barrel, not the other way around. Recreate them again, click one, it explodes. And if I click where two overlap, both should explode because I don't have that loop breaking when it finds a barrel to explode. If there's an overlap, yeah, it explodes them all. But we don't have the chain explosion behavior yet, but it's still pretty fun to just click on these. Okay, let's neaten this up. It's a nice thing about working vertically. If I just hit Control L, should be a nice vertical stack. Tap that one over too, great. I want to explain something we did before. If we go into mouse explode here, you can see we've got all barrels coming in and all barrels going straight out. And then over here, we're running this operation when we click the mouse. And because barrel is a class that's mutable, we can not just read properties, but set properties here, and that will set these same references that are coming in. The same barrel is being set. We don't need to reconstruct the spread with the bottom splicer and send it out as you would with records. With classes, we can just mutate them. The order of operations is still guaranteed if we go out in this context because the entire mouse explode node will be calculated before anything downstream when you do this kind of programming. So that's why I do it like that. Next up, let's make the chain explosion work. And this will involve seeing a slightly different way we can put these classes in another collection. So let's create another process here called list exploding barrels. The way this self-explode behavior is going to work is that we have a list of which barrels are exploding right now, and that should be checked by every barrel that is not exploding, and when their radiuses intersect, then it's time for you to explode as well. First part, list exploding barrels. Let's actually instance the process here. Let's go back to mouse explode and just copy paste this like to input output configuration here. And we go back out and we can put this already in the list. Great. It's already typed, so everything's running. So that means our program keeps running, which is nice. And then what we want to do in here is go for each and make a spread, a new spread based on the exploding state of the barrels. Now, I don't think I've broken that out yet. No. So we go in here, explode state. And when I'm just getting the property, then I put it in this properties block, explode state. This is a bit messy. That annoys me, so we'll just bump these around. Could use Control L. That's fine. Okay. Back out here. That's not position anymore. We want explode state. And if your explode state equals 1, which means you're exploding, we want to make a new spread. So equals 1. That means we're going to use, if you haven't seen this before, there's a keep node you can put in as a special output inside these for each loops. And then if I put something on the splicer, only the barrels that met this property, which is exploded, will be in the new list. So actually, I fear now that we haven't been clear enough, and exploded and exploding should be different things. So state 1 should be while you're exploding, but then when that's finished, we can take you to state 2, which means you've exploded and you're excluded from this calculation. The way we'll do that, still we're just going to use this animation based on the animation we visually see. So we can simply say when that is like greater than maybe 0.95, then exploded state, do this in an operation with an if block like this, because the property itself, once we're in the context of a class, is not mutable. We need to like get it to be set by something. That becomes 2. Let's see if this works now. Yeah, for start, that list is already empty, and I mean, let's just put it there. I click on something. Yeah, things should only appear in this list while they're exploding. Perfect. And we create an output here, and it's called exploding barrels. I want to point out something that's very handy now with mutable objects, which is that we now have this all barrels list, and then the references will be temporarily added to the exploding barrels list, but they're pointers to the original objects. So you can have a bunch of classes that appear in multiple different collections, and those collections are organized in different useful ways for you, sorted, for example, or by state or something, and you're still really only talking about the same instances of objects, which can be very useful property when programming. The way we're going to use that is now we're going to create another process called self-explode. Oh, neaten that up. Let's instance self-explode, set up the same input-output stuff so it's running straight away, but with a defined order of operations. Let's run another operation on every barrel, and this is going to be called self-explode check. Again, I'm just going to drop any operation there while I set up the new operation. Go in here. This time I'm going to press plus first and call it self-explode check. And what happens here, I'll create a little frame for it, self-explode check. In self-explode check, we want to take the explode state, and only if the explode state is 0, not exploded, do we care about checking for other barrels that are exploding. You see, it put that on update straight away. We want to put that on self-explode check. We want to run an if region. In the if region, we're going to look at the position of all the exploding barrels. So we need that list we created before. Put it here, exploding barrels. We won't type that yet, but I will assign it already to self-explode check. And if I go out here, that's still draw barrel. I want to make that now self-explode check. We want to run that check on every barrel, every frame, although internally we'll only run it on the barrels that are not yet exploded. Here I hold control and I'll get a pin with a name. Out here, I have that exploding barrels list. I want to put it in here. Now, because it's currently not typed, I have to hold space to force connect it. And if I go in back into here, I could start using it. We want to check the position of all the exploding barrels. Position barrel, there it is, for each. So that should type that. We compare the position to our own position, which we get in this context from the pad. Very similar to the mouse check. We go distance between this position and this position. Then if that distance is less than, this time definitely less than, so it needs to be less than both our radii somehow. I think it's just add, by which I mean if I take the radius of the exploding barrel, and bear in mind its radius gets bigger as it explodes, we have to be, that will touch the radius of this barrel, as in the barrel that's not yet exploding and doing the check. When those two circles touch, then I think this should be true. And when this is true, We are actually going to break this loop because it'll do it so many times a second that when it breaks, that's enough. So then when it breaks, this will be true, and when it breaks, our own explode state, which I'll paste here again, will get set to 1. Second if block, IO blocks of 1, connect it out, connect explode state. Right. So let's see if we get some self-exploding behavior and click on this one. Yes, great. Let's make some more barrels and check that a bit more. Do create. That looked pretty good to me. Maybe there's some little bug there. Let's try that again. They're all pretty close together, so you're almost always going to explode all of them. Let's space them out a bit more. Like size 2.2. Make a little more room for this renderer. Back out, let's create them. I think that's about right. The last bit of functionality we're going to add. So exploding with the mouse was always just something we did for testing. We want to add a function where we can select a barrel and explode it remotely. In this case, we'll use MIDI from a little MIDI controller. So let me set that up. Okay, so you should see a MIDI controller in the bottom right of your screen there. And to add MIDI to this project, we'll go dependencies, vl NuGets, vlio.midi, enable that. If we press F1, there's a great patch in the MIDI pack called Know Your Device. And if I select the right device, and then turn this, it should tell me what MIDI message I'm already getting there. So that's controller 0, number 16. The way this MIDI fighter twister works is these are also buttons. So I want when I twist the knob, I'm going to select one of our barrels, and then when I press the button, it's going to explode. And for bonus, maybe if I press that button, we're going to reset the patch. So I'm just going to copy and paste what they've already got down here. So I need channel 0, start 16. I know also there's a bug in one of the other MIDI controller state things. I've posted in the forum about a patch. Hopefully by the time you're watching this in the future, that bug's already fixed. But anyway, so actually I only need one. I know that will work. In fact, I should already be able to roll that and see, yeah, that value goes up and down. Note that in MIDI, the raw data is an integer between 0 and 127, but that's already mapped to a float between 0 and 1 for your convenience, usually your convenience. Let's go back here and copy paste that in. Oh, I think I still need the MIDI in. Just to be connected there. MIDI fighter twister. Should put all this in a process, shouldn't I? I'm going to create a process called MIDI control. All our definitions are living over there. MIDI control. There it is. Paste that in that I was working on. It's the MIDI fighter twister is the device. Yes, channel 0. I want to just get the first only slice of that. So that value will be select. Barrel select. Just put a control L on this. Much better. Going to do that again. This much of it anyway. This is going to be channel 1. Controller 16 is the button version of that, which we're going to call do explode. And I think I just copy pasted this much. 17. Controller 17. Oops, it's the same channel though, so that much goes together. In future, I'm going to do a tutorial on reactive where we'll go more through about how all these things about observables and things work. But for now, that's what happens. And we're going to preview that value now and go out, do reset. Just control L that, make it neat. Control L that, make it neat. Okay, let's just quickly test. Roll this first value, that should go that up and down. If I push that button, I should get the second one. And for the third one, if I press this button, yep, great. So back here, those are my 3 MIDI values ready. Now I need to make them do something. And here we finally get to sorting classes that I promised you back at the start. Let's create again some more barrels so we can see what we're doing. We want to sort these barrels. We don't want it to be the random selection that they're generated in. We want, when we roll that knob, a specific thing to happen, and we're going to select them by their X value, how they're horizontally arranged. So that means we need to sort them by their X value. Let's create a new process called select explode. Actually, the definition should live over here with our definitions, but the instance should be somewhere over here. Select explode. And then we connect, we create an input here, all barrels, because it'll start with what's all barrels. And then we're going to use something called OrderBy. OrderBy spread region. And what this does is sorting of any kind of spread, but you have to tell it what to sort by. And it still needs to be something that it knows how to sort by, in this case, a primitive float. To get all barrels in here, I need to connect it. That's not yet typed, so I had to hold space to force that connection. When we go in here, we want to access. So the top value here in OrderBy is the same type that the spread is made of, in this case, barrels. So I can go barrel position. That should type that properly. Still not running though until it can know the type of the bottom. In this case, we want to get the position. We can't just put the vector2 position into it. It doesn't know how to sort a vector2, but it does know how to sort a float. And if we just take the X value, put it in there, we should now have 25 barrels and they're sorted by position, which isn't so obvious when we look at the tooltip, but hopefully it's going to work. One detail here is that we don't need to run this every frame. We can put this in a cache region. I think I said cache before, which is definitely the more fun way to say it, but wrong. That's the wrong way to say it. Okay. All barrels goes into cache. Now there's a detail here, which is that the barrels are in an immutable spread, but barrel itself is mutable, as we've talked about several times. This is a bit of a detail worth watching my mutability tutorial to find out more, but basically cache is only going to run when the spread itself is updated, which only happens when we create more barrels, and that's when the position's set, so it does all the position sorting then. Okay, so to actually make one explode, we need to get a particular barrel, which we'll just use getSlice. To select that, we want to do a normalized value between 0 and 1, so we have a float that's like barrel select. And we're going to use map clamp again. When this is between 0 and 1, we want to go between 0 and max count. If we go count, spread, should be 25 of these, but better to get it dynamically. What if we change that later? That's an integer. If I put it in there, that'll go straight away. But actually, we don't want to go between 0 and 25. We want to go between 0 and 24.99, basically, so that there's an equally spaced section in the mapping for every single item index in the count. Now the problem with that is it's made it an integer type block. Subtraction there, I want to type that as float. This is all to do with, implicit conversion and generics and things like that. And look out for my upcoming tutorial on type flexibility, which will explain all of these. But anyway, that wants to be a float, 24.99. Then we've got a float at the bottom of there, getSlice as an integer. We're going to use floor, which means unambiguously it's just going to take the always rounding down, basically. And then we should have the barrel there that's selected by 0 to 1. So 15 up to 24. If I make that 1.0, yeah, still 24, which is what we want. And 0 should be 0. Great. So that is theoretically selecting a barrel. The barrel that's selected, we want to set explode. We enable that apply pin and make sure it's low before we connect it here. And then we have the input that is like do explode. You might remember actually that's a value between 0 and 1 as well. So actually when that's greater than 0.5, we do this trigger. Oh, type it as a float to make sure we get this. Oops. Then that explodes. And in fact, maybe I'll put a tog edge there to make sure that's a bang. Although the way this works, that probably doesn't matter that much. Lastly, we want to know what we've selected. So let's also get barrel position. And let's draw another circle this circle has the same position, but we're going to use stroke instead of fill. And have it like a blue stroke. Radius, pretty small, something like that maybe. There's a blue circle. Do a layer out. To draw that, I think if I had another pin here, Control plus on this group layer node, then I should be able to plug that in there. And then you can see it up there. Then need to put an input on this barrel select. Go back out here, MIDI control, we're going to put barrel select on barrel select, do explode on do explode, and over here do reset is going to connect to the do create. Again, we need to go when this is greater than 0.5. Okay, ready to test it. Okay, so when I rotate this, I am selecting exactly by the X position. And when I press it, bang, great. That's what we like. Now you see it's still selecting the dead ones. That's okay. But of course we could create that filter so that we're filtering things that are only exploded state 0 that already exist. And if I press the second button, it should reset. Oh, I didn't put a toggle edge on that, so I can hold that down. We get a lot of resetting. That's great. What if I hold both those down? Oh, nothing happens. Okay, anyway. Bang. That's kind of fun. So hopefully that showed you how to create classes, how to create operations on classes, how to put classes in different collections, and you can sort those collections, but still be talking about the exact same instance of the objects, which is very useful. One thing I haven't covered here that could be important in a much larger application is what happens if we want to delete one of these barrels. It's like a dynamic list, and then it exists in multiple collections. And that becomes a problem that takes some handling and thinking. You're like, oh, I'll have to delete it everywhere. And that means finding it everywhere, finding it by key or something, and taking it out from multiple different collections. Can all be done, but requires some thought. Can also be a problem theoretically with some versions of this when you have mutable classes that appear in multiple different collections. You could get a memory leak or something where if this is an application that's meant to run on a server, have no downtime, it makes and creates objects and their entire lifetime isn't managed, then yeah, some objects could be sitting in a collection somewhere and never get deleted because you didn't check all the collections to delete them, and then they stay in memory forever. Maybe in future I'll get around to doing a more advanced tutorial on garbage disposal and all these sort of topics. But for now, applications of this scale, media arts type use cases, hopefully you will very rarely run into that kind of problem. So, enjoy. Hope that was useful. See you next time.